Now we have learned something about an axiom. We know what is an axiom, right? What is an axiom? It's a simple statement which we accept as true without any proof. These are nothing but they are universal truth. And we know that an axiom and a postulate in today's geometry, modern geometry, we consider it one and the same, right? So we say call it as an axiom or a postulate, it's one and the same, right? And we learned, we had discussed certain axiom. One is infinite number of lines pass through a given point. Yes, it is true, we directly accept it. The other statement which we had discussed is one and only one line passes through two distinct points. So these two examples of axiom. So now we know what is an axiom. We're going to learn something more interesting, right? Observe. I'm going to give you a triangle, as you see, triangle ABC. And when we talk about triangle, it has got three angles there. Angle A, angle B, and angle C. And if I ask you, what is the sum of these three? You said, we have learnt it, we have heard about it. There's a statement which says that sum of all angles of a triangle is 180 degree. But when the statement came to you for the first time, when you listened to this for the first time, when you read it for the first time, didn't you have a question in your mind? Why 180 degree? Can't the sum be 200? Can't the sum be 150? Can't the sum be 250? It could have been, because that's the query which comes to your mind. That means you question this sentence. You question this statement. You said, I require a proof. And such a statement is called as a theorem. So what is a theorem? It's again a statement like an axiom. But axiom, we accept it without a proof, right? It is truth, we understand. But a theorem is something which requires a proof. So what is a theorem? In simple language we can say a property or a statement that can be logically proved, or that needs to be logically proved, is called as a theorem. That means theorem always needs to be proved, not like an axiom which need not be proved, right? So that such statements we call it as theorem. This was again said to us by Euclid. Now when we talk about a theorem, as we learned, a theorem is always a statement. That means it will always have a statement, right? Let's consider an example for us to understand how a theorem has to be written or proved. If two lines intersect each other, then the opposite angles so formed are equal. First of all, from the statement, we need to understand what are we supposed to draw. For that, if you look at the statement and if you find two words, two keywords, if and then you're very happy, because that's a conditional statement, and that conditional statement helps you to get something what you're supposed to draw very easily, right? If you look there, if and then, beautiful. So now you're very happy. Whatever is between if and then, observe that statement. What is that? Two lines intersect each other. In simple language, this is nothing but what you're supposed to draw, because that's a given. So what are we supposed to draw? Two lines which intersect each other. You will say, I'll draw it so easily. Line AB, line CD, intersecting at a point that is O. And whatever we have drawn is nothing but our given. That's the first part of proving. So first we draw, then we write the given. Whatever we have drawn, we have to just write it in English. That's so easy. Lines AB and CD intersect each other at point O. Finish. So we have drawn it, we have written the given. You'll see it's so easy, right? And whatever follows then is nothing but the two proof. That is the result. So what is that? What follows then here? The opposite angles so formed are equal. So which are the opposite angles here? There are two pairs of opposite angles. One pair is angle AOC and angle DOB. We need to prove them equal. That means you write in the to prove angle AOC equal to angle BOD. But is that the only to prove? No. Because when we talk about opposite angles, there is one more pair. Which one? Angle AOD and angle BOC, and that is what we write there. Beautiful. That is our second to prove, right? That means when a theorem is given, it always has a statement. From the statement, we need to understand what is the figure we need to draw, and from that we understand what is the given, followed by the to prove. So it's first the figure, then the given, then the to prove, right? Now we have to prove this. And that entire systematic way of proving it with logical reasoning. We write statement, we write reason. We write statement, we write reason. We write statement, we write reason. So that we at the end reach the desired result. That is what we wanted, is angle AOC equal to angle BOD and angle AOD equal to angle BOC. This systematic way of, logical way of writing the statements with the reason. When we are doing this, we'll use axioms, we use certain theorems which we have already learned, and this systematic way of writing the statement with the reason to reach the final desired result is called as a proof. And this is nothing but the steps of proving a theorem. So first we have a statement. From the statement we understand what we are supposed to draw, then we write the given, then the to proof, and then the proof. Isn't that easy?